Many of us tend to take our tires for granted because flying down the trail on one of these, who would think about what it takes to make them? But at Carlisle Tires in Clinton, Tennessee, they know just how these rough and tumble ATV tires get put together.
It takes up to 20 different ingredients to make a batch of tire rubber, and you can see the recipe right here. You've got natural rubber, 2 different kinds of synthetic rubber, and chemicals that help with the curing process.
All of the ingredients go down the conveyor belt into a mixer. But this is no ordinary mixer.
What we have here is a gigantic 3-story rubber mixing machine. At the top, the ingredients are coming in on conveyor belts. In the middle here, it's grinding all those ingredients together for about 4 minutes, and then the whole pile, about 500 pounds, dumps into the pit.
When it reaches the pit, this mixed rubber is hot, about 300 degrees Fahrenheit. But the heat makes it soft, so the roller mill can do its job. The mill works like a giant pasta maker, squeezing the rubber into a uniform thickness. This gangly contraption, called the wigwag machine, wags the ribbon of rubber back and forth into a single manageable pile. Now it's time to turn this pile into a tire. Coming up, we'll see how this machine turns a tube into something we all recognize. The workers at Carlisle Tires have just milled together all of the special ingredients needed to make tire rubber. Now, this massive pile of rubber is ready to become one of the 3 separate components of the tire. First, the carcass, or the tire's inner body. The carcass is made up of several layers called plies that eventually bend into the shape of the tire. Second, the bead, a wire ring covered with rubber that keeps the tire seated on the wheel rim. And finally, the tread, the tire's tough, knobby surface. The tread wraps around the carcass, forming the tire's top and sidewalls. The first step is to produce the plies that make up the carcass. But rubber alone won't keep the tire from tearing. They need to add something else to these plies: nylon.
A surprising thing about tires is that they actually contain a lot of fabric, like this tough orange nylon that you see here. It gives the tire its strength so it doesn't pop or rip on the trail.
The process of combining the nylon and rubber is called calendering, and it takes this vast array of conveyors and rollers to get the job done. First, the rubber from the wigwag gets reheated in another mill, where friction heats it to 150 degrees Fahrenheit. Those popping noises are air bubbles being squeezed out of the rubber. From here, a worker feeds a thin ribbon of rubber into the main part of the calendering machine. Inside, a nylon cloth runs between 2 ribbons of rubber and enters a set of heated rollers. The rollers squeeze the 3 layers of material together so tightly that the rubber encases the fibers of the nylon fabric. These rollers can spread a 3-inch rubber ribbon into an even 65-inch sheet of fabric at up to 40 feet per minute. The result is a solid, supple sheet of rubberized nylon.
You can see that this fabric is stretchy in one direction and really strong in the other. To build a tire, you've got to orient the fabric at just the right angle. This bias cutter slices it diagonally so it's ready for the tire assembly machine.
These separate pieces of rubber fabric are the finished plies, which will form the carcass of the tire. Workers match up the edges and send the plies onto the tire assembly zone.
Have you ever wondered what holds a tire onto the rim? I mean, it can't be flexible rubber because that would just rip immediately. So to hold the tire on, they use a metal bead like this. The fabric and rubber will wrap around this and attach to the rim for thousands of miles.
Tire beads are rings of steel wire coated in rubber. They're placed at the edges of the tire's carcass and make contact with the wheel. And because of steel's strength, the beads stay snug against the wheel through the worst bumps and roughest terrain. The first step in building the beads involves bringing together the multiple steel wires. Carlisle goes through over 1 million pounds of this tempered steel wire every year. The bead former unravels the wires from these 1,000-pound spools. Grouping the wires together in a precise arrangement. The grouped wires then run through the rubber extruding head, which gives them their healthy coating of melted rubber. Now this pulley system stretches the wires and wraps them around a forming wheel, shaping them into perfect circles. This fully automated bead former can make up to 25,000 of these beads a day. That's fast. But it turns out that the fastest hands in the factory might belong to this guy. With the plies and beads of the tire finished, we can get a jump start on the most gripping part of the tire, the tread. The tread begins its journey as a continuous ribbon of rubber and travels through the extruder where it gets its desired width.
To set the thickness of the tread, the extruder forces the rubber through a metal die like this. Because Carlisle makes so many different kinds of tires, there are actually 400 differently shaped dies like this.
The die for this ATV tire is put into place at the bottom of the extruder. Then rubber is poured into the top. Inside the extruder, pressure forces the hot malleable rubber through the die. As the rubber passes through the die, it cuts the shape of the tread. The top of the tread where the tire hits the road is thicker, while the edges, which bend over to form the sidewalls, are thinner. The tread rubber then comes out of the extruder at the perfectly determined width.
Every tire actually starts out smooth like this. This will be one sidewall, the center of the tire, the other sidewall. The tread pattern and the lettering will get pressed onto this rubber in the mold.
The mold is the final step, but before that can happen, this 1,000-foot ribbon of tread must be cut down to tire-sized pieces. And that happens here at the Skiver. The Skiver is a robotic slicer that slashes through the tread rubber with a steel blade. It moves so fast it must spray water on the tread and blade to keep the blade cool. Now that we've got the final piece, it's time to transform all of these components, the treads, the beads, and the plies, into an actual tire.
This is the heart of the operation. Every single tire that comes out of this factory is built by an operator like John. He can build about 200 tires a day, or 50,000 tires per year.
The tire builder begins by hand wrapping the plies around this expandable drum. On the first ply, the fabric cords run left to right. On the second, they run right to left. The crossed hatch pattern of the nylon fabric adds strength to the tire. Once the plies are in place, the drum expands. Now it's time to attach the beads, the wire rings that hold the tires onto the wheel. Here's how that works. 2 bead cans snap the beads into place on both ends of the tire. As these 2 bladders inflate on both ends, they fold the edges of the rubber-coated fabric back over the beads, locking them into place. The tire builder then slaps the tread right over the plies and wraps it around the drum, sealing it at the edge. Finally, these wheels roll out any air pockets that might be trapped between the layers of rubber.
There's your tire.
So every tire that comes out of this factory is really hand-built like this.
Every piece.
That is amazing.
But this doesn't exactly look like a tire. That's because it's still something called a green tire, which means the rubber hasn't been cured.
First, the rubber is soft and kind of sticky like bubble gum. And second, there's no tread pattern on the tire. Both of those problems are solved here in the mold.
The mold actually imprints the tread pattern into the rubber. First, workers place the tire over an expandable steam bladder. When the steam bladder expands, it presses the rubber into the hot mold. Then the mold heats up to 350 degrees Fahrenheit. Finally, after 15 minutes of heat and pressure, the rubber is vulcanized, meaning its molecules have formed crosslinks. That makes the tire stiff, smooth, and tough. It's now a finished ATV tire, hot off the press and ready to hit the trail.